Hi everyone. Today we will see the question paper, Physics Paper 3, Theory Core, February-March 2023. Question number 1. Figure 1.1 shows two strips of staples. The width of one strip is 56 mm. There are 40 staples in a strip. So width of one strip is given and there are total 40 staples in the strip. Calculate the average width of one staple. We need to find the average width of one staple. So average width can be found by what is the total width divided by what is the number of staples. Here the total width is given as 56 mm and the total number of staples it is 40. So 56 by 40 will be equal to 1.4 mm. Next, a student wants to find the volume of one strip of 40 staples. The student has a measuring cylinder and a beaker of water. So a measuring cylinder is there, a beaker of water is there. We need to find the volume of one strip, that is of 40 staples. So how we can do that? Describe how the student can determine the volume of one strip of staples by using the equipment. So first we will pour this water into this measuring cylinder. And after pouring the water, we will be we'll take the reading. So first reading will be taken and then we will put this stapler into this one. So automatically the measuring cylinder, that reading will change. Next, we will note down this reading and we can take the difference of first reading and second reading. So here the answer is, first we need to fill the cylinder with water. Then take the reading. So this is your first reading. Then you can put the staples. Put the strip in the water. Again, you can take the reading. That is your second reading. So volume of the strip will be the difference in volume. We have obtained two volumes. We need to take the difference in volume. That is your second reading minus first reading will give the volume of the strip. Now the staples are made from a block of metal. The mass of the block is 296 gram. So mass is given as 296 gram. The volume of the block is 33.2 centimeter. So volume is given as 33.2 centimeter cube. Calculate the density of the metal, include the unit. So density is equal to mass divided by volume. Here the mass is given as 296 gram by volume is 33.2 centimeter cube. So after dividing, you'll be getting the answer 8.92 gram by centimeter cube. So density of the metal is 8.92 and the unit is gram per centimeter cube. A student has a spring of length 14 centimeter. She stretches the spring by adding different loads to the spring. So one spring is being provided. So she is stretching the spring by adding different loads. She measures the length of the spring for each load. She plots a graph of the result. So here length of the spring is given in y-axis and load is given in x-axis. So gradually she is increasing the load and the spring is getting stretched. That value also it is given. Use the graph to determine the length of the spring when the student adds a load of 8 Newton. So she is adding a load of 8 Newton. So 8 Newton is here. At that time, what is the length of the spring? So from graph we can write. So this is 8 Newton. So this line we can extend. So this is the point. So here we can see it is 20 centimeter. We are joining this line. This is 20 centimeter. So the answer is 20 centimeter. Length of the spring will be 20 centimeter. Use the graph to determine the load added to the spring when the extension of the spring is 7 centimeter. So at 7 centimeter, what is the extension of spring? So starting it was 14. So now it has extended to 7. So 14 plus 7. That will be equal to 21. So we need to find at 21 what is the load at 21 centimeter. So this is 20. Here total 5 divisions are there. So this will be, here it is 22, right? So middle of this will be 21. So this is 20, 22, middle of that will be 21. So at 21, what is the load? So if you're drawing a line from this 21 and it will be crossing at this point, right? And extending towards downside. So here it is, this is the line and there is total of 8, that is here it is 10 and each division it is 0.2. So here it is 8.2, this will be 0.4, 0.6, 0.8 and this is 9. So this point is 9, this will be 9.2 and this is actually 9.4. The line is between 9.2 and 9.4. So your answer will be 9.3. So at 21 centimeter, the load will be 9.3 Newton. Complete the sentence about the effect of force. Choose a word from the box. A load Stretching a spring is an example of a force changing the size and dash of an object. So when the spring is stretched by the load, its size and shape will change. It will get stretched and the shape will change. So here the right answer is shape. A clamp stand used in the experiment has a weight of 8.6 Newton. Calculate the mass of the clamp stand. So weight W can be written as mass into gravity. We need to find the mass. So mass is equal to weight divided by gravity. Here the weight is given as 8.6 Newton and the gravity we know that is 9.8. So after dividing, we'll be getting the answer 0.88 kilogram. Figure 3.1 shows the distance time graph for a cyclist. The journey has two sections, PQ and QR. So in y-axis, distance is shown, and in x-axis, time is shown. And it is having two sections, that is one is PQ, other one is QR. Calculate the speed of the cyclist in section PQ. Speed can be written as distance by time. Here distance is given, time is given. We can take it from the graph during PQ. So this is the section. So what is the distance? That is 250. Distance is 250. And the same way time. You can extend this line. So this is actually 10. If we extend that line to x-axis, it will be 10. So the time is 10. So distance is 250 and time is 10. So the speed will be distance by time, that is 25 meter per second. Describe the motion of the cyclist in the section QR. There is no change. It is just 250 only. No distance is being covered. So it will be, the person will be at rest or stationary. So your cyclist is at rest. There is no change in distance at QR. Figure 3.2 shows a bicycle fitted with wide tires and a bicycle fitted with narrow tires. Two bicycles have the same weight. People use bicycle fitted with wide tires to ride over soft grounds. So explain why people uses bicycles fitted with wide tires to ride over soft ground. Use your ideas about pressure. So we know the equation of pressure. Pressure is equal to force by area. As area increases, pressure decreases. From this equation, it is visible. As area increases, pressure will decrease. So when your tire is wider, it will have larger area of contact. So wide tire means wide tire have large contact area. So it applies less pressure. The pressure applied will be less in the case of wide tires. And as the pressure on the ground is less, it is less likely to sink. It is less likely to sink in smooth or soft grounds. Next, figure 4.1 shows some gas at room temperature in a cylinder with a piston that can move. So here we can see one cylinder is there, some gas molecules are there, one piston is there. The gas cannot escape from the cylinder. Describe the movement of gas particle. Normally, gas particle, it will move freely in all direction. Next, describe how the gas particles exert a pressure on the walls of cylinder and piston. So when the gas particles are moving freely, there will be collision of particles. So this collision of particles with the walls of the cylinder and the surface will exert a pressure. When the gas particles that are moving freely, so these gas particles will collide each other. It will hit on this surface of the cylinder piston that will exert a pressure on the walls. The piston in figure 4.1 moves to left. That means it is moving left towards this side. So now the piston may be in this position as it has been moved towards left. The volume of the gas decreases. Volume has decreased. The temperature of the gas does not change. State and explain any change in the pressure of the gas when the piston moves to left. Here the area of cylinder has been decreased. When it is moving towards left, the total area inside the cylinder, it has decreased. Before the area was more, now the piston has moved towards left, the area has decreased. So we know the relationship between pressure and area. That is, pressure is equal to force by area. Now here area has decreased. So what will happen to pressure? It is inversely proportional. So the pressure will automatically increase. So the answer is here. The area of the cylinder decreases. And the collision per unit area increases. And finally, the pressure increases. Area of the cylinder is decreasing, the collision will be area small means the collision between the particles will be more. Collision per unit area increases and the pressure also will get increased. Next, this question is about work energy stores and energy transfer. Figure 5.1 shows a child pulling a toy trolley across the floor. So here 12 Newton is given. The child pulls the toy trolley with a horizontal force of 12 Newton. The distance moved is 5 meter. Calculate the mechanical work done. So mechanical work done can be written as force into distance. Here force is given as 12 Newton and the distance is 5 meter. So 12 into 5 it is 60 Joule. Figure 5.2 shows a candle burning. Describe the energy transfers taking place as the candle burns. Your answer should refer to the energy stores as well as transfers between energy store. So, in this candle wax, there is chemical energy is being stored in the candle and it is converted to light energy. Here, the chemical energy stored in the candle decreases. And that energy is being converted to light energy. And here, heat energy is produced in the surroundings. When the candle is glowing, light is produced. Along with that, heat energy or thermal energy is generated. Near the surroundings. Next, figure 6.1 shows the displacement of a transverse wave that is varying with time. This is a displacement time graph. Determine the amplitude of the wave. So how we can find the amplitude? That is the maximum distance from this zero crossing point. So from this time axis, this zero crossing point to maximum distance, the peak value that is 2 centimeter. So the amplitude is 2 centimeter. Determine the frequency of the wave. So from this graph, we can find the time period. So what is the time period? That is the time required for one full cycle. From this node to next node. Full cycle means 360 degrees. This full cycle we need to take. So the time period is, here it was written 0.2. So the time period was 0.2 seconds. So how we can find the frequency? Frequency is equal to 1 divided by time period. So it is 1 by 0.2 seconds. That will be equal to 5 hertz. Describe the motion of the particles in a transverse wave. In the case of transverse wave or water wave, transverse water wave, the vibration of the particle will be always in perpendicular to the direction of propagation of wave. perpendicular to the direction of propagation of the wave. A wave has a frequency of 400 Hz and a wavelength of 0.9 meter. Calculate the velocity. So here velocity can be written as frequency into wavelength, that is f lambda. Velocity is equal to frequency into wavelength. Both are given here, that is frequency is 400 Hz and wavelength is 0.9 meter. Just we can multiply, we'll be getting the answer as 0.9 to 400, that is 360 meter per second. A student places a book in front of a plane mirror. So one plane mirror is there. So a student is placing one book in front of plane mirror. State three characteristics of the image of the book formed by the plane mirror. So plane mirror means it will be forming a virtual image. And it will be of same size of this book and it will be of same distance. From mirror to this book and from this mirror to this virtual image, the distance will be same. So one is, it is a virtual image. Always this plane mirror, it will be producing virtual image. Size will be same. It will be having same size of the book. And same distance. From the mirror, same as the book. Visible light is one region of electromagnetic spectrum. Another region is UV or ultraviolet radiation. Give one use of ultraviolet radiation. We can use ultraviolet radiation for sterilizing water. Give one possible harmful effect of excessive exposure to ultraviolet radiation. It can cause skin cancer. Its radiation can cause skin cancer or skin damage. A student uses a dry cloth to rub a plastic rod. So a dry cloth is there, one plastic rod also there. This is a plastic rod. This is the cloth. State how the plastic rod gains a positive charge. So now the plastic rod has gained positive charge from the friction between the cloth and the rod. So if it is gaining positive charge, the electrons from the rod has moved towards the cloth. That's why it has gained positive charge. That is, electrons from the rod moves towards the cloth. So when we are rubbing, initially it will be having both positive and negative ions, and it will be releasing these negative ions to this cloth. So the cloth will become negative charge and the rod will become positive charge. Three balls P, Q and R are electrically charged. The balls are suspended by thread of insulating material. Charge on ball P is positive. State the charge on ball Q and the charge on ball R. So here we can see always like charges repel each other and unlike charges attract each other. So this is moving forward, that is, it is repelling. Repelling means the Q should be positive, then only it will repel, like charge. And this Q and R, it is getting attracted. So this is positive means unlike charge, attract. So this needs to be negative. So charge on the P, Q is positive and charge on R is negative. The student connects ball P to earth with a copper wire. Charges from the earth flow in the copper wire to ball P. State the name of electrically charged particles moving in the copper wire. So P is positive, so always it will attract free electrons. So when it is connected to ground through a copper wire, the electrons will be moving from this ground to free electrons will move towards P. The particles moving, it will be free electrons. Figure 9.1 shows an electric kettle. The power input of the kettle is 1.5 kilowatt. The potential difference of the mains electric supply is for the kettle is 220 volt. Calculate the current. So power can be written as voltage into current. That is P is equal to P into I. We need to calculate the current. So for calculating the current, we can write I is equal to, it will go to denominator, that is P by B. Here P is given as 1.5 kilowatt and voltage is 220 volt. So after changing this kilo means 10 raised to 3. 10 raised to 3, that means 1000. So 1.5 into 1000 by 220. That can be written as 1500 by 220. That will be equal to 6.8 amps. So here the current is 6.8 amps. Next, the 1.5 kilowatt kettle is used for a total of 4 hours. We are using it for 4 hours. The cost of 1 kilowatt hour, it is 14 pennies. Calculate the cost of energy used by the kettle in 4 hours. So cost of energy can be written as cost of energy is equal to power into time into cost of 1 kilowatt hour. Power is given as 1.5, that is for 4 hours, and the cost is for 1 kilowatt hour is 14. So after multiplying, we'll be getting 84 pennies. Next, figure 9.2 shows an overloaded extension box. You can see here, this extension box, it is been overloaded with so many plugs. Explain the danger of connecting too many plugs to an extension box. So when you're connecting too many plugs, each will draw current, right? This will draw current, this will draw current. So the current drawing will be more. So as more current drawing means heat generated will be more, and it will not be able to withstand that current and heat, and eventually it will get damaged. So when you're connecting more plugs, it will try to draw more current. And cause overheating. Next, figure 10.1 shows two coils of wire P and Q. P is there, Q is there in each circuit. The end of the coil are closed but not touching. So this is not being touched. Now switch S is closed. This is being closed. And the pointer in the sensitive ammeter G, this will deflect and then turns to zero position. Explain why the pointer in sensitive ammeter G is deflecting. Actually, it is due to mutual induction. Here, when switch S is closed, the current will start flowing through P, and there will be change in magnetic field. When the current starts flowing through this one, through P, a changing magnetic field will be there, and thereby an EMF will be induced. This induced EMF will be transferred to Q through mutual induction. As there is an EMF induced, this ammeter G will deflect. That means whatever current it is induced in this P, same will get induced in the Q also because of mutual induction. When switch S is closed, current will start flowing through coil P. As the current starts flowing through coil P, there will be change in magnetic field. That induces an EMF. And that will get induced in same EMF, get induced in Q also. That means current flows in Q also. That's why the ammeter G is deflecting. Describe the construction of a step-up transformer. You may draw a label diagram as part of your answer. So step-up transformer means the number of coil in the secondary will be more. So we will have a rough diagram, that is transformer. It will have iron core, primary will be there, primary coil. Step up means secondary, number of turns will be more. So we need to draw more number of turns in the secondary. So this is your iron core. So this is primary coil. This will be secondary coil. Next, Americium-241 is a radioactive nuclide. The nuclear notation for the nucleus of Americium-241 is 24195 AM. So this represents the mass number, and this represents the atomic number. Mass number means it is the sum of number of protons and neutrons. Atomic number, it is the number of protons. Determine the number of protons in one nucleus. So number of protons means it is directly we can take, that is atomic number, that is 95. And neutrons in one nucleus. Neutrons means here mass number it is given. Mass number means that is number of protons plus number of neutrons. So total it is 241. So we need to find number of neutrons. So we can subtract mass number minus atomic number or number of protons will give the number of neutrons. So 241 minus 95, that is 146 is the number of neutrons. Americium-241 has a half-life of 430 years. The radioactive source contains 12 mg of Americium-241. Calculate the mass of Americium-241 that remains in the source after 860 years. So we can use one formula, that is Nt equals N0 into 1 divided by 2 raised to T by T. Here Nt is the current amount and N0 is the initial amount of the radioactive source, and T is the time, and capital T is the half-life. So capital T is your half-life. This T will be your current time given. That is, here it is 860 years and the half-life is 430. So T by T, that is 860 by 430, that is equal to 2. And initial amount, that is 12 mg. Source is 12 mg. So 12 into 1 by 2 raised to T by T is 2. That is equal to 12 into 1 by 4. That can be written as 3. So the mass remaining, it is 3 mg. In this way you can find, or you can find like this: 12 mg, half-life is 460 years. So after 460 years, it will be 6 mg. So this 6 mg again after 460 years, it will be 3 mg. That means here our time was 860. Sorry, it is 430. So total it is 860. After 430 it is 6 mg. Again after 430 it is 3 mg. So total of after 860 it will be 3 mg. In either way, we can find the answer. State in order the names of three planets closest to Sun. So Sun. So next to Sun, it is Mercury. So after Mercury, it is Venus. Then Earth. So closest to Sun, it is Mercury. Next, it is Venus. And next, it will be Earth. So define a light year. Light year means it is the distance traveled by light in 1 year. Distance traveled by light in 1 year. Jupiter is 7.8 into 10 raised to 11 meter from Sun, and the speed of the light is 3 into 10 raised to 8 meter per second. Calculate the time for the light to travel from Sun to Jupiter. So speed can be written as speed is equal to distance by time. We need to find the time. So time can be written as time is equal to distance by speed. Here the distance is 7.8 into 10 raised to 11 meter. And the speed of light is 3 into 10 raised to 8 meter per second. So 7.8 by 3, that is equal to 2.6 into this 10 raised to 11. This 10 raised to 8 will go on the top. So it will be minus 8. So it can be written as 10 raised to 3. So it is 2.6 into 10 raised to 3 seconds. Seconds will go on the top. 2.6 into 10 raised to 3 seconds. So thank you for watching. We'll see in the next video.